Hello everyone. Your today class, today experiment is going to be about simple and fractional distillation. We have two major types of distillation: simple and fractional. Uh, in our previous lab, we performed crystallization, which is a purification technique for solid compounds. We purified benzoic acid, which is a solid at room temperature. But crystallization technique is not applicable for compounds that are liquid. So when we have a mixture of liquid and we're gonna separate the a liquid from a mixture of liquids, we use distillation based on the difference in relative volatility, or in fact based on difference of boiling points of the liquids in the mixture. So distillation is heavily utilized in different industries. For example, in beverage industry, distillation is used to make wine or beer. In petroleum industry, distillation is used to make gasoline or diesel. So as I've mentioned, we have two major types of distillation: simple and fractional. So for simple distillation, the setup of the simple distillation, we have three major components. The first is boiling a liquid mixture. So we will have our mixture of the liquids in a round bottom flask, and by using a heating mantle, we boil the mixture. So the second step is condensing the vapor. By using a condenser, which we have a flow of water, cold water, water will be go into the condenser from the bottom and will go out from the top of the condenser. So here the vapor of the liquid will be condensed, and so we can collect the condensate in a graduate cylinder. So based on the different boiling point, so our different liquid in the mixture will be convert to vapor and then again convert to liquid in different temperature. And so in different temperature, we can collect different liquids. So simple distillation cannot separate a mixture of liquid with close boiling points. It effectively works only when the mixture of liquids have boiling point differ more than 25 Celsius. For example, we can use simple distillation to separate methanol from water. Why? Because the boiling point of methanol is 65 Celsius, but the boiling point of the water is 100 Celsius, and so the difference is 35 Celsius, more than 25 Celsius. So for separating methanol from water, we can use simple distillation. Uh, if I'm gonna again mention to the simple distillation setup, let me use the example of mixture of methanol and water. So when you use simple distillation to separate methanol from water, after heating at a temperature around 65 Celsius, which is the boiling point of the methanol, so the methanol will be evaporated, and after passing through the condenser, it will be liquid, and so you can collect the pure methanol at the temperature around 65 Celsius. But if you continue the heating step, so at temperature around 100 Celsius, the water will start to be evaporated, and it will go through the condenser. It will be condensated, and it will convert to liquid, and you can collect the pure water. So the liquid which you are collecting at temperature around 65 Celsius is methanol, and the liquid which you can collect around the temperature around 100 Celsius is pure water. But about fractional distillation. So for fractional distillation, again, we have the three major steps exactly same to the simple distillation. Boiling a liquid, condensing the vapor, and collecting. But here we have an extra step, a fractional column. So the major difference between the simple distillation setup and fractional distillation setup is fractional column. So while simple distillation cannot separate a mixture of liquids with close boiling points, fractional distillation can do it. In fractional distillation, the vapor is passed through a fractional column before entering into the condenser to cool and to be collected in the collection flask. So, a fractional column contains hundreds of obstacles inside the column to restrict a small passage for the vapor. So the vapor hit the obstacles, condensate to the liquid. The condensate inside the column continues to be heated by the rising vapor, those vaporizing once more. Therefore, the vapors undergo a repetitive condensation, vaporizations, and so it will continue the condensation vaporization cycles inside fractional columns. Each condensation vaporization cycle will yield a pure solution of the more volatile components following Raoult's law. So let me explain how you can set up a simple distillation. So as I've mentioned, you need a heating mantle. You need a round bottom flask. You can clamp it by using a ring clamp. And so you will have a three-way adapter. So the three-way adapter, the bottom way will connect to the round bottom flask. The top way will connect to a thermometer adapter, which we will use it for connecting a thermometer to the simple distillation system. And the third way will connect to the condenser. But you need to know that you need to grease each of these way before connecting to the round bottom flask, the condenser, and the thermometer adapter. Because after heating and after doing this experiment, because you heated the system, so without greasing, so you cannot separate the glasswares from each other. So for your water system, again, I'm going to mention that water will go into the condenser from the bottom arm and it will go out from the top arm. So the water flow will be from bottom to the top of the condenser. So about the fractional distillation setup, everything is same. Just as I've mentioned, we will have a fractional column here. So without connecting the three-way adapter directly to the round bottom flask, you will connect your fractional column to the round bottom flask, and you will connect the bottom way of the three-way adapter to the fractional column. So, as I mentioned, the most important thing which you need to know is that is about water flow. So water flow is going to be from bottom of the uh, condenser to the top of the condenser. So I'm going to again emphasize that water should go in through the lower outlet and come out of the condenser through the upper outlet. So the flow will be from the bottom to top. So however, you're not going to do the experiments because of the online course, but you need to know that. So after doing the experiment, you need to draw the graph milliliter of distillate versus temperature. So you need to collect your distillate. Each 1 milliliter which you collect in a graduate cylinder, you need to record the temperature and finally you supposed to draw the graph of the milliliter of distillate versus temperature. So guys, that's your today course. Good luck.